Hey everyone, welcome back to Fly with Shubham, and today we'll be discussing the approach plates, how to read an approach plate, and what all components are there. So, today, as an example, I've taken an approach plate of Udaipur, and this is an old approach plate. I don't have the updated one with myself, but we're just doing this for practice, so this will be useful for us. Okay, now the very first thing is we always read the approach plate from the right hand side, not from the left, because all the approach plates on the left hand side will have the same name. So let's say you're sitting in the cockpit with another pilot and the captain or whoever it is with you. They open the approach plates. If you read it from the left, you wouldn't know which approach plate you're opening, right? Because all of them have the same thing written on the left hand side, as you can see. But since we will be, we want both the pilots to be on the same page, we will read it from the right hand side first. That is the very first most important thing. Now before we go into the detail of this, the important aspect is, why do we need approach plates? What is the purpose of an approach plate? And how we use them in the cockpit. So many of the airlines now usually have iPads in their cockpits, which allow them to access all the approach plates wherever they're going, whatever they need, all the details on their iPad itself. And you can find the updated latest approach plates over there, and you can read through it as per your approach profile of that particular flight. What is the purpose of approach plates? Now, approach plates are of different variations. They allow you for instrument departures, they allow you for arrivals, they allow you to make precision, non-precision approaches. So it can be used in various different ways, right? Uh, Coming to one of the points that I just told, what is precision and non-precision? So precision approach is basically where you have lateral and vertical guidance. Basically horizontal, which is the centerline guidance, and vertical, which is the glide slope guidance for your height and proper descent profile, right? That is a precision approach. When you have both horizontal and vertical guidance, it is known as a precision approach. And a non-precision approach is where you won't probably have the vertical guidance. You'll probably just have the localizer or the horizontal guidance, which is there, right? So we are not going to go into too much detail, as there are many different types of approach plates, and there will be a lot of time that will take for each of these approach plates detailed description. So what I'm going to do now is, for this video, we'll specifically be discussing the Udaipur ILS Zulu runway 26 approach plate. Okay. Now, the first thing which might come to your mind is, what is ILS Zulu, right? Over here we have this letter Z, Zulu. So the purpose is, ILS is for the instrument landing system approach for runway 26 Zulu approach. That basically means that in different terms, Zulu is often the primary approach, and there is another one which is Yankee, which is the secondary approach. And the Zulu approach is mostly via the arc and using two or more instruments, and Yankee will be probably either via overhead or something like that. It will not necessarily be via the arc, but it will obviously also have a DME if the DME is available, right? So now that we've understood, this is your airport name, Udaipur. ILS is for instrument landing system. Okay, landing system. Your Zulu is for the type of approach. Okay, which will be, this one is via arc. As you can see, this is the arc, and we are going towards the final course. And this is for runway 26. That is the first step. And then we go towards the left, from the right to the left. And this initial portion, as you can see over here, this portion, it's known as the briefing strip. Okay, then comes the plan view. And over here you can see, usually what happens in a single approach plate, there will be a profile view below, but since this approach is more detailed and it is a bigger chart, so you have a separate chart which says for final approach C111A. So yeah, we'll go into the detail from here itself. Okay, so this is the approach plate for Udaipur ILS Zulu runway 26, applicable for category A, B, and C aircraft. Issued by, it's made by Jeppesen on the 18th Feb 2022, effective from 24th Feb. So this is the issue date, and this is the effective date, as you can see below. And this is the index number. So this one which you see in the oval, it is known as the index number. Okay. Now in the index number, there are three numbers you can see here: 1, 1, and 1. Okay, the first one is what indicates your primary airport. Okay, for example, if Delhi has two different airports or three different airports, let's take Delhi has two airports, which is the Indira Gandhi International Airport and the other is Safdarjung. So the primary airport is the Indira Gandhi International Airport, so it will have the first number as 1, which is for the primary airport. And for Safdarjung, the first number will not be 1, obviously, it will be number 2. Okay, so it depends on number of airports in that particular state. And the first number, again, indicating the primary. The second number is indicating the type of instrument. Okay, so 1 is used for ILS, 3 is used for VOR, and just like that we might have many different approaches. Okay, so for the first one, primary airport, the second one is for the type of instrument which is used, which is ILS over here, and the third is the chart, which is for this particular runway. We have the first chart. Okay, so yeah, that is your index number. After the index number, on the left hand side you can see the 4 letters here and then 3 here. So the first 4 letters over here, Victor Alpha Uniform Delta, that is the ICAO code. Okay, ICAO identifier of this airport. The right one is the IATA code of Udaipur, and the name of the airport is Maharana Pratap. Okay, so that's the initial portion from right towards the left, explaining each of these components. The next, you come down below to the briefing strip. The first, you have the D-ATIS with you can see a small star on the left, which means it's not active all the time. D-ATIS is digital ATIS, frequency 128.85, and then you have Udaipur Tower 118.65, 122.3 alternate. Okay, and besides this, below that you have your localizer frequency and identifier India Uniform Delta Romeo. Okay, so with a star as well, 109.9, which is your frequency for your Udaipur localizer for runway 26. Final approach course 262, and refer to chart 11A 11-1A for your final approach course. ILS decision altitude, again refer to the further chart. Airport elevation is 1684, runway elevation 1664, so that's a 20 feet difference. And this small circle that you can see over here, this circle basically is your MSA, which is your minimum sector altitude or minimum safe altitude. Okay, now this MSA, what people generally they forget is that it is from a particular location. Okay, and as it mentions over here, MSA uniform delta VOR. So basically this means that the minimum sector altitude mentioned here in these three different sectors, the northwest quarter, then southwest quarter, and then the eastern quarter. Okay, so in this particular section, as you can see, the MSA is from the uniform delta VOR, and the distance of this MSA is standard 25 nautical miles from this particular VOR. Okay, so towards the entire eastern sector, as you can see, we can see from 360 to 180. So basically the entire eastern area, we have our MSA as 4000, which means we have to maintain a minimum of 4000 feet in this particular region. Okay, and towards the northwest and the southwest regions, okay, towards the northwest region we have 5400 as the elevation as the MSA, and towards the southwest region we have 4700 as the MSA. Okay, so whenever we are coming for approach from any of these particular sectors, let's say I'm coming from the northwest, I have to maintain minimum 5400. If I'm coming from the southwest, I have to maintain 4700, and if I'm coming anywhere from the easterly region, I have to maintain minimum of 4000 feet as an elevation in within 25 nautical miles of uniform delta VOR. Okay, now this is a really important thing, because most people tend to forget where is this distance from. Some people say it's the entire sector, some people say that it is from the airport reference point. So let's say over here it is already given uniform delta VOR, so we know it is from the VOR. Now if, for example, in some approach plates you might not be given this VOR, or it might not have a nav aid, so what will be your reference? Your reference will become the airport reference point of that particular airport, from which the MSA would be applicable. Okay, now this completes the briefing strip. A small portion over here, altitude set in hectopascals, runway elevation 59 hectopascal, transition level by ATC, transition altitude by 6000 feet standard. DME is required for this approach. Okay, so you can see it is all written here in the briefing strip, clearly visible. Okay, now coming to the plan view. Plan view is basically a kind of a top view from for your entire approach profile, as you can see here. Okay, so you can imagine your aircraft going along these lines from wherever you're approaching, something like that, and then coming in for the approach. Now we just have the arc here, right? We don't have the details of the profile or our final approach course. So the first thing to understand here is it says for final approach C 11-1 alpha. Okay, so there's another chart which is the alpha chart of this chart, which will probably be on the next page. I'll just check it. Yeah. So you can see here 111 alpha. Okay, this is the course, the final approach course, and the final details with the profile view as well. So we'll talk about this in detail. First, let's complete the plan view over here. So over here you can see in the plan view you have a lot of different markings on the entire area, and some of the references I'll tell you. Okay, towards this portion, as you can see some small numbers towards this bottom over here, this and this, these are basically your longitudes and latitudes. So on this side you can see your latitudes, and this side you'll be able to see your longitudes. Okay, so over here you can see your latitude 24 degree 20 minutes north, and so on. It will go 24 degree 30 minutes north over here, and over here you can see your longitudes. Okay, these are mentioned on all the approach plates mostly for your references. Now, coming to the approach plate, we have the Udaipur approach with DME 115.9 frequency for your VOR uniform delta. VOR will always be in 3 letters. ILS will be in 4 letters, as you can see here, preceded with an I, a letter I, India. Okay. Now 262 final course, so 109.9 frequency, India uniform delta Romeo. Okay, and what are these dots and dashes below that we can see below these numbers? This is basically the Morse code. Okay, the Morse code identifiers for your approach plates. Okay, as you can see, India uniform delta Romeo. Now how do we know whether we've tuned into the right frequency or not? How do we know whether we have tuned into the right viewer or not? So basically these 3 letters, uniform delta, they are understood by the Morse code, which is given here, dot dot dash dot dot dash dash dot dot. Okay, so when you tune into the frequencies, you can use the cockpit instruments to listen to the Morse code and identify whether you're tuned into the correct frequency or not. Okay, this is basically a Morse code identifier for your viewers or NDVs or your instruments. Okay, the next thing is over here. You can see a lot of these small dots. These small dots are basically your elevated points in this region, which are mentioned. Okay, and this one with the big arrow is basically the highest elevation point. So you can see here in this particular region we have a lot of dots, right? A lot of elevated points, and you can see one structure here, you can see one tower sort of here, and this one you can see 3035 feet. Okay, 3035 feet, that basically means that's like the highest elevated portion over here, which may be important if you're doing a missed approach or a go around, something like that. Okay, and it's a critical area because it's coming within the approach region of Udaipur. Okay, so that's why it's always mentioned here. So mostly on your plan view you will always have one of these indicating the highest elevated zone in that particular region. Now, since we have an obstacle here at 3035 feet, you can see that's why our MSA is always minimum 4000 at least in all the sectors, right? Giving us 1000 feet clearance above that particular obstacle. Okay. The next thing is you can see here, let's start from here. So you have IAF, India Alpha Foxtrot, that's initial approach fix. Okay, DME 15.0 uniform delta. So basically this is an initial approach fix point. So an approach will basically have 5 different stages. Okay, so yeah, an instrument approach will have basically 5 different segments. The first is the arrival segment, the second is the initial approach, then your intermediate approach, then your final approach, then the missed approach. Okay, so over here, initial approach fix, that's the first point. Let's say you're coming from this particular sector, you're coming from this direction, and then you want to join, let's say I'll put an aircraft here. Okay, you're coming in from this direction, so you might be joining at this particular fix initial approach fix at DME 15. Okay, so basically you're joining the arc, you're joining the approach from DME 15 nautical miles from the station. Okay, that distance is given. That's your initial approach fix. Okay, now following the arc, turning left, you go maintaining a 13 DME arc uniform delta. Now using that VOR as a reference and maintaining 4,000 feet throughout this entire arc. Okay, you'll be going maintaining the constant distance of 13 DME. Okay, 13 DME, maintaining a constant distance from the VOR. Okay, which is your uniform delta. So something like this. Okay, maintaining a constant distance throughout the entire arc. So this is one joining point, this is another joining point. Just like that, you have different initial approach fixed joining points which are given as a reference, okay, to join that arc. Now over here towards this particular portion, you can see Udaipur frequency 115 decimal liner, uniform delta. We've already talked about this. Final approach course 262. Now what are these 2 points? We can see over here this point and these 2 points. Now this point is mentioned as IF, that is intermediate fix. Okay, now this intermediate fix is at 13 miles uniform delta, maintaining 4,000 feet. Okay, and over here you have DME 6.4 India uniform delta Romeo, and below that it says Foxtrot 126. That's basically your fan approach fix. Okay, what are these two numbers? These are basically called lead radials. Okay, lead radials are basically your critical points where you have to start your interception for your final course. Whichever side you've joined the arc, let's say you're coming from this particular direction, you'll keep flying the arc, maintaining 13 nautical miles, and maintaining 13 nautical miles. Once you cross the radial 073 with respect to uniform delta, that is your lead radial, and you'll say crossing lead radial, and you will go and join the final approach course 262. Okay, now over here you can see 6 miles 262 3,700. So from 13 miles till 6 miles you have to descend to 3,700. That's 300 feet descent. Okay, and over here you have to keep going 6.4 your final approach fix 262. Now we don't have more details ahead of this. Okay, so once we have intercepted our lead radial, once we've crossed our lead radial and we are turning for the final approach, we can change the approach plate onto our final approach plate 11-1 alpha. Okay, now moving ahead to the 11-1 alpha approach plate. I hope I've covered everything here. If I've missed anything, please mention it in the comments below, and yeah, let me know. So moving ahead to 1-1 alpha approach plate, which is the final approach plate for ILS Zulu runway 26. Okay, coming on the same approach plate, the entire section remains the same, frequencies and everything is the same as we've discussed. Now over here, fan approach course 262, DME 6.4 is your India uniform delta Romeo, fan approach fixed 3,700 feet, and this small one in the bracket 2,036 feet. This is basically your height. Okay, the first one you can see is your altitude from the mean sea level. This one is your height from the ground level. Okay, ILS decision altitude and height refer to minimums. Minimums are written at the bottom of the page. We'll go there. Airport elevation, everything is same. MSA is the same as we've already seen before from uniform delta viewer, 25 nautical miles. Remember that, that's important. Missed approach, climb straight ahead to 3,000 feet, then climbing, turn left to join viewer holding at 4,700 or as directed. Now, missed approach in the plan view is given as this dotted line. Okay. Altitude side hectopascal and all this remains just the same. DME is required. The same points are here. 3035 is already there for initial approach. Now we are already done with the initial approach. We are looking at the final approach fix. Okay, so we are approaching from 13 miles, maintaining 4,000, and we are gently descending to 3,700. Okay, so descending to 3,700. So we were over here 13 miles, and we are 4,000 feet. We are gonna descend to 3,700 feet till we reach final approach fix of 6.4. Okay, now over here once we reach that, we can continue our approach course for 262 final course, and we will keep going till DME1, which is our missed approach point. Okay, and we'll go to the missed approach point. Then if we cannot if our stable approach is not there, or if we cannot see the runway, then obviously we'll do a missed approach as per the procedure. Climb straight ahead 3,000 feet, and climbing turn left to join we are holding. Okay, now this climbing turn left, you can see there's a right hand hold here, okay, from the fix, and the outbound leg is 258, inbound leg 078 for the hold over here. A right hand is a standard hold, left hand is a non-standard hold. Okay, other components remain the same. Now over here we have some small tables, as you can see over here. LOC, GS out, basically localizer glide slope out. So if you are not getting vertical guidance, so you were supposed to do an ILS approach and all of a sudden you lost the glide slope, or maybe there's some instrument which is faulty, or there's some problem with your aircraft and you do not have the glide slope in your instruments, what do? You still continue the approach using the localizer, but for your altitudes you can use this reference of this table. Okay, so at 6 miles you should be 3580. Okay, I'll just zoom in a little so you can see a little better. 6 miles 3580, 5 miles 3260, 4 miles 2940, 3 miles 2620, 2 miles 2300. Okay, you can use this table as a reference for doing a non-precision approach. So you were doing a precision approach, your glide slope went out and your instrument's not working, so now it becomes a non-precision approach only with horizontal guidance. Okay, now over here the profile view mostly indicates via overhead the viewer. So let's say you're coming from any place and you're coming over at the viewer and then you're doing the approach. That is what it indicates. Okay, it does not indicate via the arc what you're doing. And the other thing is, if you're doing via the arc also, you're coming in from outside just like this, maintaining 3700 just like we talked here, and you're going to join the final approach fix and then start your descent profile. So in the profile view you can see 4700 over at the viewer, okay, and then descending following outbound radial 078 and then intercept localizer. So this will be the back course. Okay, intercept localizer back course 082, and then you keep going out descending to 3700 till 6.4. At 6.4 you have to do this reversal, which is a procedure turn, okay, to the right hand side. So you can see you came via overhead. For example, you're coming from somewhere here, you come over at the viewer and then you keep going outbound 078, intercept localizer 082, which is the same thing that's given here as you can see. Okay, and then 082 6.4 you turn right, intercept heading 127, fly as per the procedure, turn inbound 307 to the opposite side and intercept your final course 262. Okay, now you intercept your final course maintaining 3700. So this will be a level procedure turn over here 3700. So reaching 6.4 over here via over it, you should be 3700. Okay, after that, once you reach your 6.4 final approach fix again, you start your descent as per the profile. If you have glide slope, just go with the glide slope. If you don't have glide slope, make it a non-precision approach, follow this table, okay, for your reference. And you keep descending as per the profile. This distance is given where you will, have the glide slope at 3260 feet. You keep descending and you go till your points. Okay, now a precision approach will generally have a much lower minima than a non-precision approach. Okay, because a precision approach is comparatively much safer, it gives you much more allowance, and a non-precision approach is supposed to be more safer, so we cannot penetrate the MDA. Okay, that is why the non-precision approach will have a missed approach above your MDA, and a precision approach will probably go a lot lower below that, but as per the minimas as well. Okay, now over here you can see that this is the runway. You have runway elevation 1664 feet and it is leading as it's showing as a constant continuous descent. Okay, so this is also known as CDFA, which is continuous descent on final approach. Okay, this means you're continuously descending without stopping, without going in a sort of like a step descent or something like that. You just go continuously descending at a constant angle as much as you can. Okay, now mostly the rate of descent and everything, since you're on autopilot in the bigger aircrafts and the jets, it's being managed by your aircraft as much as possible, variable because of winds and gusts and all that. But in your training phase, when you're flying during your training, during your CPL training, manual aircrafts without autopilot, you're going to be have to managing your approach speed as per your approach speed and your rate of descent, right? So your angle will be as per that. Now ground speed, let's say a Piper Archer for example will maintain somewhere around 75 knots for approach. So it says 70, 90, 100, 120, 140, 160, right? As for the ground speed, it is given as per the standard rate of descent of 3 degrees glide slope, you will have this much ROD. Okay, so 75 will give you somewhere in between around 400 feet per minute, 372, 478. So that's 70 and 90, right? We're coming in at 75, somewhere a little above 372, around 400 feet per minute, sufficient enough for you to have a continuous descent on final approach when you're coming in for landing. So if you maintain an ROD of 400 feet with your ground speed of 75 knots, you will be consistent on your final approach descent. Okay, these are all the references that are there. Now what does this say? HIALS, PAPI L. So this means high intensity approach lighting system. PAPI is on the left hand side of the runway. Okay, and this is short for the missed approach procedure that was given above. So this is climb straight ahead 3000 feet. Since in critical situations or in very hectic situations, it's not possible to read the whole thing sometimes, or people might miss it or not remember it. This thing is given here as a reference in a shorter, much quicker, understandable format. Okay, now these are the minimas as we discussed above. Over here it says ILS refer to minimas, decision altitude. Okay, now a few things to add here. One thing is DA and the other thing is MDA. Okay, DA is decision altitude. Okay, decision altitude is for precision approaches. MDA is minimum descent altitude. Okay, now you cannot descend below this altitude, okay, for safety reasons. Now this is for non-precision approaches. Okay, and mostly when we are doing non-precision approaches, we also when we are doing approaches, we also have something known as DDA. Okay, which is derived decision altitude. Okay, now derived decision altitude is basically a small buffer of 35 to 50 feet above your decision altitudes or MDA which is given. Okay, this allows for buffer. Basically, let's say if I'll just draw it here on the back side. So if this is your MDA, okay, and you're coming in for a non-precision approach, if you come in and do your missed approach at the MDA, your engines will take a little while to respond. Basically, in other words, they're going to take time to spool up, right? So what happens, you might end up bursting the MDA and going below by the time your engines respond to your full power action, right? We don't want to do this because this is not safe. Our priority is to maintain critical safety limits, right? We have to maintain our safety standards as much as possible because that is what it is all about, being safe, right? So if we burst our MDA, that will be a hazard. It might be a risk. We might end up hitting some obstacle or something like that below, which we are not aware of, which we might not be able to see during bad weather or bad visibility. What we are doing here is rather setting a small margin of 35 to 50 feet, and the aircraft comes, you do a go around, you give full power, the engine takes time to spool up, and still it goes above rather than bursting the MDA here. Okay, so you're still above the MDA. That's called DDA, derived decision altitude. Okay, and it is a standard 50 feet mostly which is used, and it depends. In some flying schools they use 100 feet as a buffer. In standard procedures 50 feet is used. Some places they also use 35 feet. So it's depends on the standard operating procedures of that particular organization. Okay, now coming to the minimas over here, for a straight landing, if ILS is working, your decision altitude will be 2000 feet, and for category A, B, and for category C it is 2010 feet. Okay, and this is the height, as you can see, 336, 346. The same thing if your approach is a non-precision approach, your glide slope is not working, you can see that the minimas are a little higher than the precision approach minima. So 2090 feet, 426 feet. So that gives a buffer of approximately 80 feet for a non-precision approach. Okay, these are minimas for the non-precision approach. This will be minima for the precision approach. Okay, for category A and B, the RVR minimas, if everything is working, is 800 meters. If your approach lighting system is not working, 1500 meters. For category C, 900 meters if everything is working, 1600 meters if your approach lighting system is not working. Okay, for your non-precision approach, minimum RVR 1300 meters, 1500 if ALS is not working for category A and B. For category C, 2000 meters, and for category D is not applicable. Okay, and in the bottom you can see PANS ops written here. So basically this is in collaboration, it's following ICAO standards of document 8168, ICAO doc 8168 PANS ops. Okay, that's procedure for air navigation services operations. We have DA in lieu of MDA requires height loss adjustment. So you can see this is what it says over here. So this is basically indicating that requires height loss adjustment means you need to have a DDA so that your aircraft does not have that height loss below the MDA. Okay, so VNAV approach, non-precision approach in lieu of your MDA requires height loss adjustment. That is what we are doing here with the DDA part. Okay, and changes airport name, new AM concept. Now this is in old chart, so we're not going to talk about that, and that's it. So overall, this is how you read an entire approach plate. This is how all the components of the approach plate are there. The details from right to left, then the briefing strip, the MSA, the plan view, your descent profile in a non-precision approach if your glide slope's not working, profile view, your rate of descent graph, your lighting systems and missed approach, and your minimas for your precision non-precision approaches as per the availability of your instruments. Okay, yeah, that's about it for the approach plate discussion. If there's anything I might have missed out, then please let me know in the comments below. And the next time we'll be discussing viewer approach plate for the same. Let's do it. Let's do that for next time. And if you want me to discuss some other approach plates of some other country or some other states or something like that, then do mention it in the comments, and I'll try to do that as well as much as I can. And yeah, looking forward to see you again. Thank you for watching.